Let's now talk about another type of distribution function. See if you can guess what it is. So pause the video, read this. All right, so we are talking about a hypergeometric distribution function. If say this was a very, very, very large herd, or we could replace the cows that we took from the herd of 450, i.e. there was replacement, it would be a binomial. But because as we take cows out, that affects the probability of the subsequent choices. So that's why it's not independent, and that's why we don't use binomial, we use hypergeometric instead. So binomial and hypergeometric are related, where binomial are independent, and hypergeometric are used for the same problems, still for similar problems, but for when the data is dependent or not independent. So we're looking at a hypergeometric distribution function here. So again, let's try and do a bit of active learning. So what are the things that you think we might need? Or let's put the data in a little box, okay? So what have we got? What's the population size? What's the number of events in the population? What's the sample size? And then number of events in the sample. Okay, so pause the video and fill these out, or you might have been doing that as I was going through. So population size is how many? 440, good. How many events in the population, i.e. how many infertile cows are there? 11. What's the sample size? 14, no surprises there. And what are the number of events in the sample? And we don't know. That's what we're going to try and figure out. All right. So let's draw our table. So X, where X is the number of events in fertility or infertile cows. And then P, and then this column is the probability of that particular event occurring. All right. So let's fill up our table. So for this one, equals hypergeom tab. All right, so this sample, what's the number in the sample? Or so S here stands for successes. So sample success is what? Comes from this column, great. What's the number in the sample? Good. What's the population success or number of infertile cows in that one? Great, good. And what's the number in the population or the population size? No surprises there, cool. And we'll do cumulative. Now, because we have used, you can see here it's highlighting these ones, because we have used these, we don't want these to shift down as we pull this one, as we copy this one across. So we do need to go and put in our dollar signs, dollar bills that make them stay the same. Sweet. All right. So this is what we get. So there is a, say, 70% probability that the number of infertile cows in that sample size of that, or the group that we buy off the dairy farmer, will be 0. So actually, in most scenarios, if you buy 14 cows from this other farmer, probably none of them will be infertile, provided that this other dairy farmer isn't going to try and swindle you and give you the infertile ones, but that probably wouldn't be in his or her best interests. All right, and so there's a 95% chance that, because it's cumulative, there's a 95% chance that one or none will be infertile. And this one makes a bit more sense to do it the other way, like with a just with a probability mass, so not cumulative. But you could also just go kind of like this, like 1 minus this number. So the chance of getting 2 or more infertile cows in your herd is less than 5%, which is pretty good, really. But let's chuck it in a graph. Let's only go to here because that's probably all we need. Scatter plot. Actually, I'll show. No, we'll do the other thing as well if we do. All right, so this one, Hypergeo. So we'll do the same thing. We'll just plug in. We'll just make it a mass probability function. Sample population success function 40. So it should be. Oh, whoops. Yes, and. All right. Okay, cool. So let's plug this one in a graph. Well, it scatters as always. So let's put that here. And again, let's label these bad boys. And this one, none of the reference cows bought from bankrupt farmer. And we label this one where n is the sample number. So n is a sample number of, so that many. D is the number of positives, and M is the population size. How do I label that? Oh yeah, and population size. Cool. So basically, all the actual numbers we plugged into there. So the probability that exactly 2 cows will be infertile is about 5%. But then there is a 99% chance that 2 cows or fewer will be infertile if you buy them from the bankrupt farmer. Cool. I think that concludes it. Any questions, leave a comment. Bye.